Welcome to the deep dive. If you're anything like us, you probably picture construction sites, steel, mud, lots of hard hats. But underneath all that, there's this huge digital shift happening. We're moving way beyond clipboards and someone walking around occasionally. We're talking high-tech, real-time digital monitoring. So our mission today for you, the learner, is to really dissect the source material we have on computer vision for real-time site monitoring. We're not just going to list features. We want to analyze this profound shift, focusing on how visual AI is genuinely changing safety and quality assurance on these massive, complex projects.
Right, and to really get into it, we need a solid definition of the core tech. We're talking about computer vision, CV. It's a branch of AI, artificial intelligence, that basically empowers machines not just to see images, but to understand them. It interprets complex visual stuff captured by cameras, sensors on site, turning light patterns into, well, useful data, actionable information. It's more than just a photo. Think of it like a live 3D analytical model of the whole site.
Okay, let's unpack this. Because in construction, the stakes are just incredibly high. Human lives, massive budgets, traditional methods, they rely on spot checks, right? Scheduled audits. So there's always a delay. Latency is kind of built in. You might only find out about a mistake maybe days, even weeks later.
Yeah, and that delay is critical. Exactly. So the need for real-time data is driven by this fact. Failure in construction, whether it's a structural problem or an accident, it just gets exponentially more expensive the later you catch it. And we should probably acknowledge the setup challenge up front. I mean, the promise is huge, yes, but we're talking about deploying pretty robust high-res sensor networks. Sometimes LiDAR, thermal cameras, plus regular cameras, and it'll go all across these big, messy, changing sites. The initial cost, the CapEx, it's significant, and it has to integrate with existing systems. It's definitely not plug and play. It's a major tech undertaking. That's a really important reality check from our sources. Okay, so now we understand the complexity of getting the system in place. Let's talk about its first big job. Safety, protecting people. How does this constant visual analysis shift us from, occasional checks to a true 24/7 digital watchdog?
Well, operational difference is pretty profound. These CV algorithms, they're trained using really sophisticated models. Think object detection like in self-driving cars.
They learn patterns, behavior, what should and shouldn't be there. The system watches live video feeds from cameras placed strategically, and it's constantly checking what it sees against a database of safety rules.
So what kind of specific risks can it pick up on?
Okay, so for instance, it's actively looking for PPE compliance, personal protective equipment. Are hard hats actually on heads? Are high-vis vests zipped up? Safety harnesses, are they clipped in correctly when someone's working up high? It spots those violations.
That sounds almost perfect. Like it eliminates all risk.
But, I mean, where does it struggle? Do the sources talk about the limits, like false positives? Does it flag things that aren't really problems?
Yes, that's absolutely a core implementation challenge. You hit on it. If the system cries wolf too often, generates alerts for things that aren't actual violations.
Yeah.
Maybe a worker's vest is just hidden for a second by a tool, or it confuses yellow tape with a missing barrier. Then the safety manager, the human who has to respond, they get alert fatigue. They might start ignoring warnings.
Right, which defeats the whole purpose. Exactly. So the system's reliability really hinges on the quality and sheer amount of training data used to make the algorithms smarter, more nuanced. To help with that, the more advanced systems don't just detect objects. They often use things like geofencing, 3D spatial analysis. They know where things are, so they can identify if a worker walks into a restricted zone, like inside the swing radius of a crane, without authorization, or if scaffolding isn't secured properly, which the sources really highlight as a super high-risk area for failure.
Okay, so it's getting smarter than just, is there a hat?
Much smarter. And this early, precise identification, that's the so what for you, the listener. It gives immediate, actionable information to step in before something bad happens. That directly cuts down liability and, most importantly, saves lives.
That ability to intervene in moments, not hours or days.
Yeah.
That's a fundamental change for safety. Okay, let's pivot now. From preventing harm to ensuring quality, making sure the building itself is going up correctly. This connection between the physical work and the digital plans. This is where it gets really interesting, I think. How does CV actually compare what's built with, the architect's design?
Yeah, this takes us right into digital construction management using something called BIM, Building Information Modeling. The quality control part works because the CV system is constantly capturing 3D spatial data. Often it uses LiDAR scanners, maybe photogrammetry from drones. These create dense point clouds, basically millions of measurement points showing the site exactly as it is right now.
Like a super detailed 3D snapshot.
Exactly. Then the system does a real-time overlay. It maps that captured physical data, the point cloud, directly onto the approved digital BIM model, the master plan. So it doesn't just look at a wall. It measures its percent geometry, its position, its angle, everything, and compares it instantly against the design specs.
Wow. So if a structural beam is put in slightly wrong, maybe just by a fraction of an inch, but enough to cause problems later,
Yeah.
the system flags that deviation immediately, not, next Tuesday when the surveyor visits.
That's the idea. Instant feedback. And our sources point out something important here. The difference between checking the geometry, like the position, and checking compliance with specifications. So they're related but distinct.
Right.
Precisely. The BIM overlay handles the geometric part. Is the column in the right spot? Is the concrete slab the right thickness? That's checking against the blueprint, the shapes, the specification check. That can be trickier. Specs detail things like material types, the grade of steel, the strength of concrete, maybe how long something needs to cure. Standard visual CV can spot some obvious material defects like cracks, but full spec compliance might need more, maybe integrating thermal sensors to check concrete curing temperatures or spectral sensors to verify material grades, perhaps.
Okay.
So if the system sees, for example, that a critical support hasn't cured for the required time before the next load is applied, it flags it instantly.
And that lack of delay, that's where the real economic benefit comes in for you, the listener. Because manual QA lets errors pile up. Fixing a misaligned beam after 2 more floors are built on top, that means demolition, huge costs, massive delays. The sources suggest CV can shrink that detection to fix cycle, say, in steel erection, from maybe 48 hours down to potentially less than 1 hour. That could save enormous amounts of money on big projects.
It's all about minimizing that cost curve of fixing mistakes. You catch it while the person who made the error is potentially still right there. The fix is cheap, relatively speaking. You catch it weeks later, it can become a major structural headache. So the system acts like this incredibly diligent, nonstop quality auditor that never blinks, never stops measuring. Which leads us perfectly into the third big area, overall project efficiency and this digital advantage. Assuming the system works well for safety and quality, how does this change the basic economics and schedule of a complex build? Well, it really brings up the question of automation versus traditional methods just for gathering data. Manual inspections aren't just slow, they're intermittent, right? There are gaps. There's that information lag we talked about. CV monitoring, however, is continuous. It's immediate. The speed just drastically shrinks the time needed to make decisions.
Yeah, okay, manual is slow, we get that. But I think what's more critical is the kind of data CV provides. When you automate all that routine checking, which is prone to human error anyway, you free up your most valuable people, your experienced safety officers, your quality managers. They stop being just data collectors and become high-level problem solvers, strategists.
Exactly right. It's an efficiency boost driven by much better resource allocation. And crucially, CV doesn't just spit out alerts. It generates consistent, structured data, metadata. This data can feed directly into project management software, scheduling tools.
So it connects everything.
Yes. When you have continuous, measurable proof of progress or lack of progress, you can run predictive models much more accurately. This helps construction firms cut down on those big, expensive contingency funds they usually need. They can predict cash flow better, create much more efficient, reliable construction timelines. It's basically moving construction from analog guesswork towards digital predictability.
Okay, so let's try and pull this all together. What does it all mean? We've seen computer vision really pushing the construction industry's digital transformation in 3 key ways. First, much better proactive safety through that 24/7 monitoring.
Mm-hmm.
Second, assured quality control by constantly comparing the build to the digital plan, the BIM model.
Right. High fidelity comparison.
And third, big efficiency gains by cutting out delays and using people and resources more effectively.
And connecting this to the bigger picture, the source material really frames computer vision as this key enabling technology. It allows the physical construction site and the digital plan to merge, creating a functional, real-time digital twin of the project. Its power to quantify risk, verify compliance, speed things up, that's only going to grow as the tech gets better and hopefully the initial costs start coming down.
It really does feel like a paradigm shift, moving from just oversight to continuous visual intelligence. Okay, so one final thought for you, the listener, to chew on as we wrap up this deep dive. If computer vision can monitor something as complex and dynamic as a construction site watching for safety issues, tiny structural flaws, worker movements, or other industry inspection process, one that currently relies on human eyes checking for defects or quality.
Mm-hmm.
What's next? What's on the brink of this kind of visual AI takeover? Something to think about as the machines keep learning to see.
Indeed. It's a fascinating space. The ability of machines to see and interpret our world is really just getting started, and construction is one heck of a demanding proving ground for it.
Thanks for diving deep with us today. We'll catch you on the next one.